So I'm going to get started here with an introduction to ponds, because as we move forward in this workshop, we're going to get into a lot of different topics, and we want to make sure that you have an introduction, and that if we use some terminology about the ponds, that you're right on track with what we're talking about and what we mean. So when we first get started, we're talking about what kind of pond do you have and what is the purpose for your pond. There's a lot of different ponds we're going to talk about today, and a lot of what we talk about will work for all the different ponds. But as we go forward into it, kind of understanding the different ponds you have is going to be helpful. Oh my goodness. Gotta be kidding me. Now I'm not moving forward again. All right, folks, this isn't that hard, but today it is. My middle screen disappeared that allows the advancement. So if somebody has a thought on it. Oh, no. Did I just switch to the wrong one?
We're at why was the pond built? So I think you're at your next slide.
Oh, okay. Hey, then it's maybe working.
Progress.
It might just be a little delayed, so.
Oh, that could be. Okay, so why was your pond built? Is this a recreational pond? Is it for fishing or wildlife? Perhaps the pond was built to stabilize gully erosion in agricultural areas. That's one way we did a lot of ponds in the past in agricultural areas. If you've got erosion in a gully coming out of crop fields, sometimes we would actually build a dam and flood it with water, because then that area can't erode anymore. Sometimes they're created for livestock watering sources, and sometimes they're stormwater management. So there's a number of different reasons for building different ponds, and the way where your pond originated may make a difference in, looking at some of the pond issues and things that we're going to talk about going forward. So that's always a good thing to have in mind. So I want to talk about the 5 features of ponds to make sure that we're kind of all in the same place on that. So we're going to go over what is a pool, what is a forebay, what is a dam, what's the outlet pipe, and a little bit about the watershed. So when we're talking about the pond, the pool is the main water body of the pond, kind of what you would think of as a pond. That seems kind of basic, but as we look at some of the other things, it starts to kind of hone in. A forebay. Not every pond has a forebay, but understanding if your pond does have a forebay, what you're looking at and why it's there. So a forebay is a smaller area that often collects the flow into a pond, which, when we start looking at some of the different kinds of ponds, some of them are even more, it's more important as you look at that. It creates a place to be able to clean out any collected sediment that's flowing into the pond. And it's easier to clean out that small space than the entire pool of the pond or dredging the entire pond. So, in this photo, you can see the smaller area with kind of a berm in between and then some rocks. And this smaller area is where some of the pipes come in and the water gets a chance to settle out the sediment before moving into the larger part of the pond. So that is what we mean when we say forebay. And if your pond doesn't have one, that is, the way some ponds were built also. The other topic is dam. And a dam is if the pond is built, an earthen berm will keep the water in the pond unless it's a dugout type pond. So that is what we're talking about when we say pond dam. So your pond would only not have a dam perhaps if it was actually dug below the surface of the ground. So if you have a pond and it has a dam, or that earthen embankment, it's really important to keep trees and shrubs from growing on it. They weaken the structure of the dam by putting the root channels down into it. Sometimes the dam can be also used as an access path. That's one of the easier places to get across, because the other end of the pond might be sort of marshy as water's flowing into it. So here you can see a pond dam where they have actually done mowing, and that's the pathway across. One of the other key features to look at if you're looking at your dam or the area of your pond is that generally we have an emergency overflow, or sometimes called an auxiliary spillway. So that's two different words for a lower spot on, likely it's not on the dam, but maybe on the edge of the dam. We try not to have water flow over dams, but sometimes, you know, as you're looking at where that is, there will be a lower spot that the water can flow across in the event of a very large storm event. And that is if the main spillway, which is usually an outlet pipe, is not able to take it all, so that we don't have water just going over the dam or willy-nilly. We know where the water is going to go and we can protect for it. So those are some key terms that will help as we move forward. The outlet pipe. So generally, most ponds have an outlet pipe that helps to set the elevation of the water. So otherwise, it's, you know, flowing over perhaps a weir, and I believe John's going to show some pictures that look like that. But most ponds use a pipe to set the water elevation. And it's really important to have some kind of a guard on those to help keep that pipe clear of debris. So in that upper picture, you can see, well, it looks kind of like a black hole and we're kind of at a funky angle, but that's an outlet pipe that doesn't have any guard on it. So anything that's floating in the water could come and go down that pipe and perhaps jam it up and then cause the water to move to the auxiliary spillway or create a flooding situation. The other thing to think about with ponds is, you know, if we're looking at some of the older ponds, the old outlet pipes can rust away, which can lead to pond failure. So there's a lifespan of those types of pipes. And so sometimes, you know, if you're having some issues with your pond, it may be that your outlet pipe is you know, rusted and has some holes and causing some issues. And so, you know, looking at the condition of the outlet pipe, now that would be the downstream side. So looking at the downstream, where the pipe and the water from that leaves, that area may need riprap, which is an erosion stone to help protect the dam from failure, so that if you have water coming out, you're not eating away the backside of the dam, because you know, as the water moves downstream, because that could cause pond failure in the future. And then a lot of our urban ponds can actually manage for water quality and quantity, and they've got some design parameters, especially on the newer ponds, that can really allow some specific things to be happening as you're, you know, dealing with ponds. So I'll show you a little bit about that. And what we call those are multi-stage outlet structures. So that would be something where there are multiple ways and places that the water leaves the pond in order to manage for the small events for water quality by holding that water in a pond long enough, but then still allow the bigger storm events to pass through the structure and not cause flooding issues, while protecting against those flooding issues as well. So it's a real unique system to manage for all those. And so in this particular pond, in this bottom picture, you can see the outlet pipe, and this is underwater. The pond has just been built, and so it hasn't filled up yet. So this is the underwater structure that allows the small events to flow through. And then in the silo looking structure, that is a water control structure that has gates. So as the water, that's what sets the elevation of the pond, because the other structure is below ground. So whatever elevation you set that top gate at here that goes down in this structure is the level of the pond. And then the water flows over that to get out. And then if the water comes higher than that elevation, which is down in the silver silo type structure, the bigger one, when that exceeds capacity, then the water begins to go out those holes in that concrete structure. So that's what we call a multi-staged outlet. And there's a lot of different ways to design them. This is just the example I showed to show you, you know, what it looks like. Here's a couple examples of some other ones. So the middle bottom picture shows that inline structure. In the last picture, it was, you know, in in a big metal or steel container, and in this it's a box, and so those gates are in that box because it's a little bit of a smaller structure here. So the water goes through that concrete pipe and then comes up over that structure to set the water elevation. And the one on the far right, that is a unique structure that allows the water to flow out. You can see the higher and higher concrete places for the water to flow over. That's kind of a visualization as the water increases in the pond, it gives more surface area to exit the pond, while exactly managing the different storm events we're trying to manage. So that's kind of a newer approach that we're utilizing in our urban areas to be able to manage our stormwater for water quality as well as for flood protection. And then finally, the watershed of a pond is really important because that is really what contributes the drainage to the pond. The area that drains to the pond is the area that is, putting that water to fill the pond. And it could be from overland flow, like you can see in this picture coming off the hillside and crop things. Sometimes ag tile drainage comes in, or pipes that come in from urban areas. And John is going to go into the watershed information in a little bit more detail.
Yep. So again, I'll jump in now. I'm John Swanson with Polk County. Before I jump into watersheds real quick, I would reiterate the importance of Jen kind of jumped through many different outlet types there. And for many, like an HOA or a residential pond owner or a landowner, many times your goals may not be for stormwater management or water quality. But for those of you, I know there's some city folks on here. Those of you that are building ponds or managing ponds for stormwater management, that type of outlet's incredibly important. If your goal is to try and effectively manage stormwater, the success of these multi-stage outlets as far as environmental benefits is incredibly a lot greater than the traditional pond outlet where it's like one pipe. But regardless, also want to point out that whatever type of outlet structure you have, this is one of the most important things as you as a pond owner or someone who's maintaining ponds to be checking regularly. These areas, they can fail. Pipes can get clogged. Pipes do rust away over time. And just regularly checking. And we always tell our landowners after major storm events, go out there, walk your dam, take a look at your outlet pipe, make sure everything's looking good. But as we go into this, it's really important to know some of these really important things we want to make sure everyone gets out of this is these structures, all different kinds. These are the things that need to be regularly checked on. Because if a pipe gets clogged, if a dam starts eroding in a spot, it's better to catch it right away where you can fix it before a larger failure happens. Many of the bigger pond failures we've seen, there was an issue that nobody caught, and that issue kind of propagated into a bigger problem. So just wanted to reiterate that before we jump into watersheds, and we'll roll into that, Jen.
Yep.
So my job really is a watershed coordinator. So like what I do and many of watershed coordinators like myself is we go out and we try and address watersheds because we oftentimes have a pond, a river, a lake, and there's issues in that body of water. And the reality of it is if you have an issue in your pond, in this example, that issue generally doesn't start in the pond. It's usually what's coming into the pond that's causing that issue. And that's where this idea of a watershed is so important, because if you're having, say, algae problems, if your pond's filling in with sediment, soil, if you're having erosion happening in your pond, all these different things, you have a lot of trash debris in your pond, those things aren't originating in the pond. They're actually coming from that upstream area that's draining down to your pond. So then if you kind of think about it, if you want to address those areas, you have to address the watershed. You can't always do it just in the pond. And so we flip to the next slide there, Jen. Here's kind of a classic example to visualize. So this is a pond we've been working on, coming up with some fixes for. And in this case, the watershed is about 150 acres. So 150 acres drain into this pond. In this case, we're seeing a largely agricultural drainage area. Those grassed waterways, which are kind of those grassed flowage routes, you can see it flows right down to the pond. So whatever's happening in that watershed is going to directly impact this pond. And this is a pond we'll kind of walk through a case study with later. But I'll tell you, the major issue with the landowner was that upstream area that kind of looks like a very vegetated right at the top of the pond there. That used to actually be permanent pool. That used to be part of the pond that he could fish and recreate in. But over time, it's filled in with sediments, soil, which we call sediment, which has washed down from those upstream areas. So really important for whatever your pond is, think about and look at what areas drain into your pond. And depending on what you're facing, what could be connected to those issues. And that's what I'm going to go through now. So we'll go to the next slide, Jen. And so I have to break things very simply. Like, what are the top 5 things you need to know as a pond manager when you're thinking about your watershed? And to me, those 5 things for an Iowa pond owner are land use and size of the watershed. How is that impacting your pond? Sediments, also known as soil, nutrients, stormwater, and bacteria. So I'm going to kind of walk us through these 5 things. And again, think about what is your pond's watershed and how are these different considerations impacting your pond? So we'll go to the next slide, Jen. Number one of the biggest things that impact your pond is simply how big is the watershed and what land use is happening in the watershed. Fun fact, Iowa is the most altered state in the nation. We have a lot of agriculture and we have a lot of growing urban areas. And with those land changes, you have different impacts to our water. I mean, a pond is facing the same issues as our rivers and streams and lakes. It's just on a smaller scale. And oftentimes it's more directly impacted by its watershed. So when you think about watershed size, it's really important to think how much water is coming into it. If you have too small of a watershed, that can oftentimes create your pond having issues with sustaining a permanent pool. If you have a pond that's regularly really low in water, the pool is always really dwindling in the summer, that may be a sign that you have a smaller watershed. The same thing kind of goes on the opposite end. If you have too big of a watershed for your pond, you generally see a lot more pollutants coming into your pond. Imagine if you have 500 acres draining your pond, you have 500 acres impacting your pond, and 500 acres, whatever's coming off of all that area, it's all making it into your pond. So again, this is really the baseline of the talk for today, but thinking about what is happening upstream of your pond. Is it row crop acres? Is it pasture or grassland? Is it residential development? Is it a bunch of houses and streets? Is it apartment complexes or things that have even more what we call impervious surfaces, which would basically be rooftops and streets, things that don't soak in water? And we'll flip to the next slide. Now, something I really wanted to get in early in this presentation, something to think about is, do you have a stream flowing into your pond? And again, a larger watershed is generally going to form a stream. And for decades, we built ponds. We would dam up a stream. So in this picture, you can see there's like 5 different ponds here. The pond on the right, I'd have you look at that one first. So what are you seeing here? What I see is at the top of that pond, so on the top right area, you see a stream flowing into that pond. Now that stream is a sign of a bigger drainage area. So think about, is there like a stream that flows most of the year coming into your pond? If so, one thing to really consider is what is the stability of that stream? If that stream bank has a lot of erosion happening, you see soil washing off of the banks, that is going to be, it's generally going to increase how fast your pond's going to fill in. Versus if you look at the other 4 ponds on this map, I'd say look at the center one there or look at the far left one. You really don't see a stream. The center one, you don't see any stream at all. So that's what we call an off-channel pond. So there's some benefits to that, and one of them being that you don't have to worry about stream bank erosion coming into your pond. And also I'll point out there, Jen mentioned a forebay, that pond on the left there. You can see there's kind of a berm in the center of the pond. I mean, that's a forebay, which you're going to learn a lot about forebays today and the pros and cons. And one of the pros is if there's some erosion washing in soil into your pond, it's all going to get caught into that small area. The last thing I'll touch on is if you're thinking about building a pond, the days of building ponds over permanent streams, like think about major streams that flow most of the year, those times it's very difficult to do that nowadays. To build a pond over a perennial stream, you're going to need to do a 404 permit with the Army Corps of Engineers. And what that will result in is if you build a pond over a stream, you're going to have to pay for some stream mitigation, which basically the Corps views that as a negative stream impact. And you'll likely have to pay thousands of dollars to compensate for that loss of stream. So I just want to toss that out here. It's probably the only time we're going to talk about today. But unfortunately, we've seen some landowners that have built ponds. And they've built ponds before. They built them like they used to do. They dam up a stream. They didn't talk to the Corps, and the Corps finds out, and they get in some serious financial penalties for doing that, what can accrue to very large sums of money. So just really think about, is there a pond flowing into your, or is there a stream flowing into your pond? And if you want to build a pond and there's a stream there, really reach out to some conservation professionals and start that conversation to make sure you know what you're getting into and avoid any of those issues down the road. We'll go to the next slide, Jen. So number one was think about how big of an area is coming into your pond and what's the land use. Number two, the most common reason we work with pond owners is sediments or sedimentation. That is essentially soil washing into your pond and filling it up. This is a picture of the upstream areas of the DMAC Lake on the Ankeny campus before it was dredged out. Pretty telltale sign. If you've owned a pond for a long time, you're like, hey, this used to be 10 foot deep and now it's 2 foot deep, or now it's dry land. Those are direct signs that your pond is filling in with soil. And that soil, now you think about, where is that soil coming from? And we'll touch on dredging later. Say you want to dig your pond out and make it deep again. Is that a good investment if it's just going to fill in again? So common sources of sediments, agricultural fields, especially those that have a lot of tillage happening in them. You see after storm events, if you see things like this happening, the left picture there is active erosion off of a crop field. The right picture there is if you have a stream coming in. That's an example of stream bank erosion. Those stream banks can drop a lot of soil very quickly, and it's all going to wash downstream. And if your pond is downstream of that, you may want to consider, how do we fix that stream bank before we fix our pond? So if you go through the process of dredging your pond, you're not going to have to do it again in 5 to 10 years. We'll go to the next slide, Jen. Next one, very common issue in Iowa is nutrients. Here is a picture of a pond we visited this summer that has an active algae bloom happening. So that algae, you can see that green floating in the water there. Algae is a living organism that feeds off of nutrients, specifically nitrates and phosphorus. Algae blooms can be a very common cause of fish kills. And I oftentimes explain that it kind of takes the perfect storm for these bad algae blooms to happen. They have short lifespans. They feed off of this nutrients, and when they die, they can suck the oxygen out of the water and cause fish kills. Now, nutrients, phosphorus specifically, it actually is attached to that soil or sediment. So if your pond's filling in with sediments, it's also carrying phosphorus. And then nitrates are commonly attributed to agricultural runoff, to fertilizers from front yards, and even grass clippings. Grass clippings are very high in nutrients, and you need all those different nutrients making into your pond, and that's what can cause an algae bloom, especially during a hot time of year if we have a dry spell with some stagnant water. And we'll go to the next slide, Jen. So this is a tile outlet. So this is an important thing, is if you live in an agricultural area or ponds in an agricultural area, it's important to know, do you have tile drainage coming in to your pond? So tile drainage, it's an important tool for growing good crops. It's a subsurface drainage. It's going to lower the water table in those crop fields. And although it can be like crystal clear water, and usually it is, that water can be high in nitrates. So again, those nitrates, and then if you add in the sediment and the phosphorus, you can cause a rich nutrients in your pond that can cause an algae bloom. So we'll touch on what we can do about this, but walk around your pond or walk upstream if there's a stream, and identify if there's any of these tile. And perhaps those are areas that we could treat to remove those nitrates before it makes it to your pond. But again, you're looking for a pipe that's coming out of the ground, and it's although it may not be draining in the summertime, oftentimes in the spring you're going to see water pouring out of it, just like in this picture. So find out if you have tile drainage coming into your pond, and that may dictate how you try and manage your pond. We'll go next slide, Jen. Number four to five. So stormwater. So say I saw in the chat, we have a couple HOAs on here. You may have a pond that looks like this. Your pond, many of our ponds in the Des Moines Metro especially were constructed to manage stormwater runoff. That was their primary purpose. So they built all these houses. All of those houses and streets, they drain into a pipe. That pipe goes to this pond, and this pond is used to slow that water down to make sure we don't have downstream flooding and serve some environmental benefits. But for you as an HOA, when your last house was built, you probably took ownership of this pond and you're like, oh, we own a pond. It can be awesome for recreation and enjoyment. But how do you manage it when your pond is also serving double duty? Well, the most basic thing to understand with your pond is those pipes that come into your pond are what's going to carry a lot of the pollutants. So I oftentimes talk about urban runoff. It's like a pea soup. Like there's a lot of different things, but not a lot of any one thing. You don't generally have a ton of nutrients. You don't have a ton of bacteria. You don't have a ton of soils, a ton of sediment, but you have probably all those things. So the most common things that are anything that can make it into that storm sewer inlet on your street, like on the top picture there, is going to be pipelined right to your pond. And the picture on the bottom right there is a great picture because it's terrible. I mean, that's an Okoboji, and you can see the sediment plume where some soil is actually washing through that pipe. So common things to think about, like what's coming in your pipe. Could be sand? Is there soil in your streets? If there's an active erosion, if there's active construction happening, that's gonna be really important to make sure that soil doesn't wash off of that construction site and get into the pipe and then to get into your pond. Pesticides and fertilizers from front yards, bacteria from pets. A lot of folks don't know that dog waste has some of the highest bacteria of any animal in Iowa. Fun facts, Easter Lake, we were working down there looking at bacteria counts, and come to find out there were over 8,000 dogs registered that lived inside that watershed in the state of Des Moines. And we were seeing dog poop that was tracing back to or bacteria that was coming from pet waste. So we kind of went through and said, hey, that's an easy fix. If you just get everyone to pick up their dog poop, you're going to cut off that source. Last one I'll touch on there, grass clippings. Many of us may know that we're not supposed to mow or blow our grass clippings into the streets. But a lot of folks don't know those grass clippings are packed full of the same nutrients we see in fertilizers. And if those grass clippings are in the street, they're going to wash directly into that storm sewer and they're going to wash directly into your pond. So again, easy fix. If you just get people to flip that mower around and blow it back into their yard, you can cut off that nutrient source. Again, we tested some inlets. I've always kind of questioned how many grass clippings you really get into a pipe. Like, is this really something we need to worry about? We tested quite a few. I'd say an average, our results were in an average 2-week period. We were getting 40 to 60 pounds of grass clippings out of a single inlet in some neighborhoods where people were blowing their grass clippings into the street. So if that's making into your pond, it adds up quickly. Keep rolling. Jen, number 5, we made it to number 5. Bacteria, that could be pet waste. There's my dog on the right in my front yard. I did pick it up. Cattle, geese, septic systems. These are all sources of bacteria to consider. How do we minimize the amount of waste getting into your pond? And I'll tell you, one failing septic system can cause a lot of very serious health hazards. And so something to think about. And I'll wrap up with, we'll jump into the next slide. So I talked about all these issues to consider, right? Sediments, bacteria, nutrients. First step is you need to understand what of those things might be impacting your pond. And then there's kind of like, what do you do about it? So there's people like myself, many of the folks on the call on the virtual meeting today, it's our jobs to help address these things. So first I'd say, feel free to reach out to people like us and help find a professional to help you reduce these impacts to your pond. But the basics of it is the basics is your goal is to slow the water down coming into your pond, to infiltrate it, which means to get it to soak into the ground and not run straight into your pond. And usually you're going to do that by installing something upstream that's going to help slow that water down and get it to soak into the ground or drop out the sediment before flowing into your pond. But many times you may not own the upstream land, or you may not own all the houses around your pond. So oftentimes you're going to have to work in partnership with someone upstream of you. But one thing many of us can do with our ponds is you could buffer your pond, which would be the native prairie, which is in the picture there. It does a lot of these things for us. So you're going to learn some about how you could do a prairie on your pond. But buffering your pond is something many of us could do by just putting a vegetated buffer, maybe 20 to 50 foot wide around your pond. That's going to help slow down that water. And we flip to the next slide. Couple other tools that are out there that you'll hear off and on about today is wetlands. Wetlands are one of the most effective tools for filtering out nutrients, filtering out sediments, and really filtering our water in general. So we've been working, a very common thing we've been doing lately is if you have a big drainage area, what if we built a wetland at the head of your pond? The wetland filters out all the pollutants, and then after it leaves the wetland, it goes into your pond, and you're left with a cleaner pond. And that also helps us achieve some of our bigger statewide goals for water quality. And just a couple more. We'll go to the next slide, Jen. There's a picture of buffering your pond. There's a picture of some prairie strips. Terraces are another practice. So these are agricultural practices you can put up in fields to slow that water down. Again, using prairie as a tool. Next slide, Jen. Thinking about crop fields. If you have crop fields, what you want to see is reduction in tillage or cover crops, which if you see bare dirt in those fields, it's going to be more easily eroded into your pond. And so working with those landowners or just discussing, I mean, it's not a simple change. There's lots of reasons to do tillage, but discussing is that an option for the agricultural fields draining to your pond. And last slide for me, Jen, next one. And here, these are bioretention cells. So thinking we know we have ag and urban folks on here today. A lot of these practices all use prairie to try and manage. So in this case, we have bioretention cells. Rain gardens are another example. You can see the street inlet right there where water's flowing down the street and it's raining in this picture. Water's flowing into that pipe. In many communities, that pipe goes right to your pond. But thinking about, can you install practices that filter that water before getting into the pipe? And again, we know I'm just scratching the surface. There's many of us spend our whole careers doing this, but there's professionals out there that can help discuss these options. But we want to just kind of share some basic knowledge before we get into lots of the nitty gritties of pond management. We'll go to the next slide, Jen. Oh, there's my last slide. But what's exciting is there's lots of funding programs out there. Many of them are through every county's USDA service center. I just listed a few programs right there. You can also have urban conservationists. There's county and city staff that can discuss these options with you. But step into that USDA service center and ask them about, I mean, go in there and say, hey, tell me about EQIP funding or REAP funding, or call your urban conservationists, because we know this workshop's probably going to raise a lot of questions, but not everyone's going to be a pond expert after one workshop. So reach out to some of these professionals and find some funding. And there's Jen and I's contact information. Feel free to reach out to us. And then I think we're going to kick it to Steve Conradi to just talk real quickly about the DNR's perspective on some of the safety of the water. Since DNR actually does lead a beach monitoring program where they, like in this picture, have to try and make sure the water is safe if people are actually interacting with the water.
Yeah, and I think a lot of the things that you and Jen said already, and I know that my colleagues Andy and Jason are going to talk about a little bit later, are going to come to play here as well. In that, the risk in swimming or being in primary contact with that water at these smaller systems is highly variable, just like the ponds themselves are very variable, and the watersheds as well. And so really it's a calculation that kind of comes down to, what is the conditions of the water currently? It's never going to be, something that I can say, don't go into your pond in August, but you can go in June or whatever. You just have to spend some time learning how your pond reacts to different stimuluses from the environment. And then also acknowledging that, beaches are kind of their own monster in a way, where, your watershed can be very well cared for, no septic tanks, no livestock, minimal dogs, maybe minimal geese presence. And that beach sand is just so good at growing bacteria and other potential pathogens that could harm human health. And so, sand is just a really good growing medium. It stays damp, generally speaking. And so, that just grows bacteria and grows biological material really well. So just try to keep that as clean as you can through different methods like raking or otherwise. If you don't have beach sand, that could be a blessing. There may be some fewer opportunities for some of those bacteria to get in there, but generally speaking, the reason why we check at the depth that this person is standing at is because that's most likely where kids are going to put their head underwater. And so the farther you get out away from that shoreline area, the lower the bacterial concentrations tend to be. So there is some benefit to kind of, maybe a floating a dock structure, or just jumping off a dock in particular versus jumping in from a beach. That like ankle deep level along the beach tends to have some of the highest water-based bacteria concentrations that we see. So there's a lot of things that go into that, and it's really hard, again, to kind of provide a one shoe fits all kind of situation for answering those questions about risk at our beaches. The other thing that comes up quite frequently is blue-green algae, and I think Jason Euchner will probably talk about that some as well. We tend to see that these smaller systems, 0 to 5 acre ponds, which is probably the majority of what the folks in the room today are talking about managing, they tend to grow a little bit less blue-green algae as a part of their vegetation, in algae species composition. And we tend to see more like filamentous green algae. And so, one of those two is a little more dangerous than the other, with the blue-green algae producing cyanotoxins. But the biggest thing to do is to just monitor the conditions there, learn about what your pond likes to grow, and then hopefully you can also learn some management tools that can help you deal with that. But generally speaking, these are fairly safe for primary contact recreation. But you really have to take in all of the features of the pond that we've talked about, including that watershed, and then just understand that there's always going to be some risk, and you pretty much never want to get surface waters in Iowa or anywhere else in the country really in your mouth or up your nose if you can help it. So just be careful out there, and understand that sometimes these aren't the best for recreation, but as far as contact goes, but they can still fit that niche if you have the time and energy to devote to kind of monitoring them and making sure that you make sure your people are understanding that they're putting themselves in a little bit of risk by getting in that water.
First of all, I'll go ahead and share what some people are hoping to get out of this workshop. We've already talked a little bit about maintaining an HOA pond, establishing native plants around the edge of a pond in place of weeds, how to remove silt from older ponds to restore them, how to maintain new ponds in an HOA, and managing levels of algae without harming fish and wildlife. So our first question is, are there common symptoms that are telling of a failure or potential failure? And I believe that this was about the outlet structures. So I don't know if John or Jen or Amanda, you want to take care of that question?
Yeah, I can maybe start off and see if other folks have things to add, but a couple things that come to mind for me. So remember, there's a pipe you have your dam, and there's the outlet pipe that's on the front side of your dam, and that goes through the dam and lets the water out on the downstream side. The downstream side of the dam can be a weak point where sometimes you can have erosion start happening on the back side of your dam from the force of that water coming out of the pipe. So that's an area where oftentimes we put some rock down there to help hold that in place. That's one telltale sign of some potential issues with your dam. Another one would be we've had some folks that have had dam failure because when the big flood came, it overtopped the dam. And they either didn't have an emergency overflow spillway, or they didn't realize what that low spot was, and they'd actually filled it in. So most dams are going to have, on one end or the other of the dam, they're going to have a spot that's a foot or two lower. That is intended when we get, say, a 7-inch rain, that will direct water in that massive flood event around the dam. If we highly recommend people don't mess with that, or if you don't have one, you should probably discuss adding one. That's another telltale sign of what can lead to a dam failure. And the last one I'll toss out there is debris getting stuck in the pipe. So we've seen some crazy things happen where, like, especially pipes that don't have guards, where like a log or debris can get into the pipe, cause it to clog, and then forces water up and around the dam more often. And it's kind of pros and cons, because if you have a guard on it, so imagine like a grate that's keeping big things from getting in the pipe, that grate can get clogged. So you need to maintain like keeping that grate clear, like rake it off, but the grate's going to stop major things from getting into the pipe, which can be difficult, if not impossible, to get out. And I lied. One more. If you have an old pond with a metal outlet pipe, it's expected that 20, 30 years later, that pipe's going to be rusting away. And you can look down at that pipe, and if there's big holes in the pipe, that's a sign that that pipe has lived its lifespan, and it's probably time to rehab that outlet structure.
Yeah, I think those are some really good ones. I don't have a ton of things to add. I think one thing I would say is that we don't always know when a failure might occur. I mean, you might not see any sign of it if we get, the big one and all things come together and something gets jammed in there, who knows? But yeah, usually there are some things that would lead you to know that you would want to do some maintenance. And I think the other thing is that you maybe can't see necessarily, but you might know, is that when we construct ponds, like within NRCS, they have some pretty strict specifications to make sure that when you're building the dam, that you use proper materials. And I've heard and seen of other places and people where they actually throw their junk into the dam or as they're building a pond and think, well, it's good fill, but that's where water could come in and pipe through. So if it wasn't constructed appropriately, you might not be able to necessarily see that, but that could be a potential failure point, as well as the trees and things that cause those. So
All right, thanks. Next question, will the funding programs for watershed improvements have examples of upstream practices other than wetlands in urban and suburban environments?
So there's so many options of what can be done. So many of these funding programs, some of them are available statewide, some of them are specific counties. So because of the diversity of those potential practices, we call them, the things you can build upstream, we really recommend that you reach out to a professional and they kind of look at the land with you, and you can kind of talk through the different practices and then what funding is available in your county. But I will say some of the most common ones we see in an agricultural setting, I think terraces and basins, also known as wascobs. So those are like earthen embankments that are going to stop the sediment and put the water into a tile. It's going to hold sediment upstream. Grassed waterways. So if you have concentrated flow areas through an ag field, grass waterways are one of the most cost-effective ways. And then there's management practices like cover crops and no-till, and different types of buffers are probably the most common ones we see upstream of a pond. Now, if you have tile drainage coming into your pond, saturated buffers and bioreactors, and we'll touch on that real briefly later. But those are underground practices that filter the tile water. Specifically, there are 4 tile practices. And now wetlands are the biggest and most expensive thing, but they kind of do all the benefits. But there's many other, sometimes more cost effective for small pond benefit options.
All right. Oh, as a follow-up question to the common symptoms of telling a failure, potential failure, is it a good central principle to slow the water as much as possible to slow and catch the debris and mitigate the force during storm surges?
So in general, yes. I mean, the most basic management of water is you slow the water down. And when you slow water down, it's going to filter the pollutants and filter and drop out soils. Now, the thing is ponds naturally do that because water flows into your pond. It has to now, your pond will get a little bit deeper and it slowly goes out that outlet pipe. So the thing about it here is you want it to happen above your pond. You want to slow the water down and filter so it drops and cleans those pollutants out above your pond. Because if you don't do it above the pond, it's going to do it in the pond, which will help downstream, but it makes your pond have to deal with all that stuff. So all these practices, the basins, the filter strips, the grass waterways, it all falls under that principle of slow the water down. And when you slow it down, you let it be treated by oftentimes vegetation or soils.
All right. Keep those questions coming if you have any. It looks like we have one about plants that may be addressed later, but we'll go ahead and ask it now. Is broadleaf arrowhead considered invasive or harmful, and should it be removed?
I can take that one if you want, and Jason, you can jump in if you want. We do not treat arrowhead in our ponds. It is native. It can, like any native species, it can get out of control. So it may need treated. But usually we do not treat it in ours because we do not see it as an issue in ours, and it is native. But yeah, like I said, it definitely can get out of control. And if it seems like it's taking over your pond, then you may want to look at treatment options. But other than that, it's not like a really nasty plant that you would want to treat just because.
All right, Jason, do you have any comments on that?
I just responded, Amanda handled that just fine. It can grow in very high abundances and can sometimes impede use of the pond, but it is a native. The only time I would recommend if you were going to do any arrowhead treatments is try to keep a ribbon around the shoreline, because it does reduce erosion and wave action on the shoreline. It is a great plant to have.
Thank you. All right, now we have someone that shared their case study. Let's see who wants to tackle this one. I have a 5-acre pond, which was a DOT borrow pit. In the past, it's been 12 feet deep around the outside ring of the pond and 18 feet deep in the rest of the pond. Due to the drought, the pond is currently 3 feet below normal pool. For the first time, I've had significant plant growth in the outer 10 to 15 feet. If the pond goes back to normal pool, will these plants not come back next year? Or now that they're established, will they come back even though the water will be deeper?